Hello you fellow clumps of stardust, my name is Carl T. Gibson and this is KTG In the Cosmos! This is a series for all you beginners and lovers in astronomy, physics and all things science-based. We'll talk about the real science behind misunderstood conceptions in society and talk about how things really do work and operate and all the really interesting things up there that people take for granted. But before we begin, let's take a quick rain check. There will be no conspiracy topics. Because we all know, what's even the point of even bringing up the topics that Crazy Dave has imagined his mum's basement and zoomed in photos really close until they're all pixelated. We're keeping it real, folks. So, on this episode we're going to go back to the basics and do a quick overview on our solar system and where we fit in within the Milky Way and indeed the universe. So, let's begin at the beginning. Let's begin in the middle. Let's begin with Helios, the sun. Our sun, like many other suns, is a life giver and a life taker of all things. Every element in your body, the carbon, even the water that we are made up from, can be traced back from the death of stars, as Carl Sagan so graciously put. Our star is classified as a yellow dwarf, currently fusing its way through its main sequence phase. The main sequence being when a star is sufficiently hot enough to fuse hydrogen atoms into helium atoms. It's not the beginning of its life, nor is it the end. It's perfectly happy as it continues this process called nuclear fusion, which overall produces us with the heat, light and energy that we need. As explained, our sun is very happy continuing this process. Well, as far as I know. I haven't asked him, or WhatsApped him, or Facebooked him, but let's just say he is. But it will keep doing this to the point where the process will eventually stop. After all, the sun is just burning its fuel. It has to come to an end. Thankfully, we will be long gone before the sun meets Mr. Fate. However, personally watching the sun burn in the Gulf of modern day society wouldn't be a bad thing. Goodbye, man bun. Goodbye, Jersey Shore. Goodbye, conspiracy theorists and Facebook spammers. Once the sun fuses its hydrogen into helium, it will attempt to fuse helium into carbon, but will fail doing so, as the core of the sun is just not hard enough to fuse. This is when the sun will begin and undergo major change. The sun will continue to grow bigger in the phase called the red giant phase. The sun will indeed engulf Mercury, Venus and unfortunately Earth. During this period, the sun output will increase as it grows. The sun gets hotter. Approximately in 1 billion years, the sun will be 10% brighter and the Earth will be like Mars in this period. Completely burnt out and uninhabitable. The sun will eventually burn out and its outer layers of atmosphere, if you will be ejected into outer space. This is called a planetary nebula. What's left behind of it is a white dwarf, a retard star if you will, a small denser. This is around the size of a planet roughly. That will remain there for billions of years until fading out into a black dwarf, never to be seen again. Our solar system and everything we know, it will be like it never existed. Mercury. So, the next planet from the sun is the very small but strong Mercury. Mercury is kind of like that one really quack guy at school that everyone pushed around until one day he picks up a part of the chair and begins to batter and drain the life and life signs and soul out of his long-lived booties. Don't let Mercury's size fool you though. Mercury has a rather impressive gravitational pull. It has an iron core that is roughly about 65% of its mass. After Earth, Mercury is the second densest planet in the solar system. It is theorized that around early formation of the solar system that possibly something had hit into Mercury and ejected a large proportion of the outer planet into space somewhere, which has allowed Mercury's core to grow. But not to go too in depth into the planet just yet, let's press on to Venus. Venus, known as the god of love, and the sister planet to our own. This is the second planet from the sun and also the hottest, and not in the sexy way. Not because of where it's placed, but mainly of the gas properties within Venus. Venus is currently in a runaway gas effect. Carbon dioxide, CO2 for short, blanket the planet, trapping all the sunlight and heat that makes it through. Instead of the heat reflecting back into space, the carbon dioxide traps it and directs it back to the surface of the planet, which heats the planet up. The surface of Venus is so hot that lead would melt on it, and the atmosphere of Venus rains sulfuric acid, so Venus is some hot stuff. Excuse the pun. Planet Earth. Next up we have Earth, my personal favourite place in the solar system. It's full of life, very vibrant place, lots to do and lots to see. Yeah, it's one of my favourite places. Earth is a very unique place. The properties and process that take place within Earth is vital to life. The moon stabilises its axis of rotation. The churning core creates a magnetic field that keeps out the charged particles, and indeed the tectonic plates that is the living and breathing planet. This allows us to reap the lands of precious metals, to allow us to become intelligent civilization. Well, somewhat. In all seriousness, I could go on. No other Earth has ever been discovered like Earth. The media, especially journalists, can be very misleading when they say they have discovered Earth-like planets. Being in the habitable zone does not mean it's habitable. Indeed, the Earth is a gem, so don't let the media fool you. But don't turn into conspiracy people as well that believe the media is pulling we're a bunch of sheeple and we wear tinfoil hats. Bye.
Mars.
Mars at the minute is probably one of the most studied planets in the solar system. Probes, rovers and potential man missions is just some of the efforts scientists are using to learn more about the red, dead world. Just recently, scientists have revealed that they have found evidence of flowing water on Mars. I'm sure you've heard on the news. Many old theories theorise that Olympus Mons, which is the biggest volcano in the solar system, if active, well, it's currently inactive, but if it was active, if you want to be imaginative, it could possibly be heating up the ice and the undercore, which obviously with heating up the ice would allow flowing water, which as we know water is the perfect conditions for life. Me and you, bacteria, microbial life. So possibly Mars, we could be right beside Martians. Doubt it, but you know, it's fun to think. It's fun to think. However, this is complete theory, and it's fun to think of creative possibilities, but let's not fall into conspiracy. Allow certified measurements and experiments prevail. There is a lot of interesting things on Mars and possibilities. Keep your eyes peeled for the latest discoveries on Mars. Watch this space. Get it? Because we're talking about space.
Jupiter.
Now we have passed the rocky planets, we are now heading into the gas giant territory. Next up, the big boy in the solar system, which is the largest planet, Jupiter. Jupiter is big, like really big, very big. Big Jupiter is big, it's big, it's big. More than 1,000 Earths could fit into it, or every planet in the solar system could fit into it, and you'd be still left with some leg room. Jupiter is the second brightest planet in our night sky, especially next to the first being Venus, again due to the gas being highly reflective, and I'm sure its size helps well, but come on ladies, size isn't everything, right Venus? Jupiter is a gas giant, mainly composed of 90% hydrogen and the remaining 10% is helium. As much gas is there, the outer mantle is liquid hydrogen, so it's not all gassy. Being on Jupiter would be like a constant struggle with storms and winds. The great red spot on Jupiter, which you've probably seen in a lot of photos, is a storm like a hurricane that has been brewing for over 400 years. Be a nightmare. Jupiter is like our big brother. He won't let anything happen to us. He will take the punch and not even flinch. Jupiter redirects many asteroids within the asteroid belt between Mars and Jupiter. It stops these potential chaotic bits of debris from occasionally colliding with Earth. Of course, some do slip through the cracks from time to time, but let's not hope the next time Jupiter sleeps on the job that I ain't around. No siree.
Saturn.
We can all picture it now in our heads. That beautiful ring system that circles around the planet. The pretty orange and yellowish colours that the planet reflects. But what is the ring system made up of? Well, it's mostly ice. Some rock, some dust. There are about 7 layers to Saturn's ring system. So the best way to remember this, personally for me, is like the keys in music. So we've got A, B, a C, a D, a E, a F, a G. No sharps or flats. You don't want to be too, you know, crazy. Each letter represents the outer layers to the inner layers of the ring system. There is even a moon in the middle, causing a ripple throughout the rings. It is believed the ring system was formed by a partial moon being pulled into the intense gravitational pull of Saturn. Once this broke apart, it formed a ring around the planet, which over the period of millions of years cooled and solidified into a moon if it was Earth. But it's not Earth, so why are we talking about Earth? We're talking about Saturn, so it's a ring system. Or it may have been a planet that collided with Saturn. Who knows? Again, it's open to theories. The more information and data we gain from planets alike, we can further better our knowledge of the formation of the rings of Saturn. Interesting fact, the density is so low that if you could manage to shrink Saturn down and somehow put it in our oceans, it would float. Again, lots more talk about the planet, but let's press on.
Uranus.
It's getting very cold out here. We have now reached the unknown. The two planets that could have only been discovered with instruments such as a telescope. Taking the BBC name, Uranus. To stop that overplayed joke. Which is still quite funny. Uranus holds the medal for being the coldest planet in the solar system. Uranus is brimming with volatiles such as methane, water and ammonia. However, there are a couple of possibilities to why Uranus is the coldest planet of the solar system. One of these is due to the fact that Uranus is actually currently inclined by about 90 degrees on its axis. This may be due to a giant impact long ago, which may have caused the heat in Uranus' core to escape out into space. The other based around the energetic atmosphere during the planet's equinox, where the planet is most lively. However, neither of these are confirmed and currently under speculation. Until further probes go to the planet, a lot of missions, we hope to gather some information on the topic.
Neptune.
Finally, we get to the last planet in the solar system, Neptune. Like Uranus, composed of the same volatiles, Neptune is the densest of all the four gas giants, being the furthest planet out, which takes about 164 Earth years to orbit the Sun, which is a damn long time. The wind in Neptune is most intense throughout the whole solar system, up to a whopping 600 meters per second. This is still a mystery to planetary science, and especially we know wind is generated by heat from the Sun. So why is it reaching Neptune? Wouldn't make sense. However, the heat reaches Neptune, so where are the winds are coming from? It's another mystery. We think it's down to the atmosphere and the lack of friction. On Earth we have friction that slows down winds. We have mountains, buildings, etc. The wind in Neptune can carry on flying across the atmosphere and the surface without anything slowing it down. These can build up to quite high speeds, but this is why astrophysics and planetary science is so interesting. There are many discoveries and waiting to be found and explained. So get on it, kids. Get on it. So that is the solar system. Of course, we have Pluto, who was declassified as a dwarf planet, but there will be another episode on dwarf planetary bodies. So, how does it all happen? What holds the planets in orbit? How do they work? That can only be explained by understanding one of the four fundamental forces of the universe. If you'd like to learn more about gravity, relativity, and who and how this was explained, don't hesitate to subscribe, and that's in episode 2. I'm Carl T. Gibson, preparing for launch. I'll see you in orbit. You've been watching KTG in the cosmos!